works. The reason why I say that is not to apply for any job, but actually to say that we could speak about other technologies too. And also, I've written some books. Please don't read the first one, which is Beginning Postgres on Cloud, because I wrote it when it was maybe 6 years ago. And now Postgres on Cloud is definitely different, much different. But you could definitely read Postgres 13 cookbook, where you would really get a lot of understanding about the ecosystem of the open source ecosystem of Postgres. For example, I've even seen other cookbooks in the past where people tend to write about their products or the products contributed by their company maybe, but I am very, very liberal, especially while publishing the content out. So I've included all the open source ecosystem of Postgres in it, and where you really don't need to worry about any vendor lock-in, especially while working with those open source tools. And at the same time, I'm also a co-founder and CEO at MigOps Inc. We deal with migrations to Postgres from any source, could be Oracle, SQL Server, and by any chance, you would have heard about this tool called Ora2PG, and we heavily contribute to that. And also the author of Ora2PG and several other Postgres extensions is also the CTO at MigOps, Giles Darold. I think enough of marketing. I might just go ahead and talk about the topic. So it's all about simplifying the top complexities while we are migrating from Oracle to Postgres. So we will talk a general complexities, right? The first thing that everybody talks about, and when we get into a call as well. Trust me, we have done lots of migrations. And the first thing that everybody asks is about, do you have RAC in Postgres, right? Do you have RAC in Postgres? Okay, good. What is RAC? Oracle Real Application Cluster. Okay, why do we use RAC for multi-master is what everybody says, right? But in general, when I speak to the Oracle DBAs who work on the same rack setups, and also the engineers who work on making the application scale better with rack, what they say is, it's always not a good choice or a thought to write to the same schema on a multi-node rack, on multiple nodes at the same time. So you have a database schema, let's say a schema called Scott, and you have certain list of tables that are satisfying certain application logic. It is never a good approach to let a critical transactional database to load balance between the multiple rack nodes while writing to the same Scott schema. That is because internally, the way the locking, the global locking, as well as the cache exchange that happens, that could also add some complexity. So for that reason, generally, even I've experienced in the past, I mean, I'm not talking about just the experience of some of the other smart people, but I've also experienced where we create role-based services in Oracle, right? So what we do is we create a role for redirecting connections connecting to Scott to node 1, and redirecting connections connecting to Tiger schema to node 2, and we create preferred as well as available node options. So if node 1 is unavailable, then go ahead and connect to node 2 for the Scott schema as well. So we rather play with role-based services in general. So all you're trying to do is you are switching the traffic between multiple nodes, but it's really not something that's heavily used as multi-master. But yes, the switchover to another node is simple here. Similarly, in Postgres as well, you have read replicas. Of course, multi-master, I know people complained about some of the solutions in the world, right? I think there are 2 known solutions today for multi-master. Yeah, try it. But I would say, I know the design behind them, and I've seen people facing issues with it. Definitely, those solutions will not be possible without making the application aware of how to deal with conflicts. It's not as seamless as the Oracle rack replacement. So it is. So today we don't have a multi-master solution in Postgres. Period. So if somebody claims that it's done, please see the internal design. And now, talking about read replicas. So the way we approach migrations is we always tell the customer that, we have enough experience in dealing with such feature requests as well. But when we ended up migrating the customer to Postgres, right, we have never seen a situation where the single node Postgres primary wasn't able to perform better. So you may have to vertically scale your hardware, right? At the same time, while doing the migration, we may have to also integrate some of the mechanisms to make sure that the read traffic is always replicated to the read replicas, because similar to Oracle, you also have Active Data Guard option with Postgres, something like Active Data Guard. It's not called as Active Data Guard though, right? We'll talk about that in the next slide. But what I want to say here is you can always set up read replicas with Postgres and unlimited cascaded read replicas. And the read replicas are also pretty fast. If you talk about the replication, right? So you have, of course, other than streaming replication in Postgres, you also have logical replication. I'm going to talk about that as well. But you have Oracle Data Guard, for example, where it says active standby with read only, right? Where you can switch your read connections to your standby, right? Of course, you'll have to manage the failover to standby in different data center through scripting. I don't think that you have that feature with DGMGRL, if you would be aware of Oracle, right? So you definitely have to work with some kind of external scripting around for managing the failover. But in Postgres, you can achieve the same feature with Postgres itself by default. You don't have to talk about another proprietary version of Postgres to achieve Oracle features, right? And what I want to say by that is, for replication, which is similar to DataGuard, you have that feature with Postgres, streaming replication. It's one of the most robust replication mechanisms, honestly speaking, when compared with MySQL too. Because I know how MySQL does, and I was also part of Percona, and I'm speaking at Percona Live, and it's pretty robust when compared with MySQL. Because streaming replication is a byte-by-byte replication. It's a storage level replication where the write-ahead logs are streamed and the replication gets synced, or the standby is almost in a near to real time sync, because of because it's very less complex. You also have the option to enable logical replication with Postgres, which is similar to log mining or log replication with Postgres, where it's a statement apply on the standby. So you have similar feature with Postgres too, where you can set up logical replication, and the same logical replication is kind of used with some more, wrappers on top of it as a multi-master by today's world, right? In Postgres. I mean, so you could do that yourself, or maybe you could even buy the license for such logical replication oriented multi-master from some vendors as well. But I would say you already have logical replication, so you could use that yourself in case. So the only advantage with logical replication in this case is that if it's streaming replication, you will not be able to write to the replicas. But if it's logical replication, you will be able to write to the subscriber, because logical replication follows a publisher and a subscriber model. So you will be able to write to the subscribers, right? And at the same time, as long as you're making sure that you're not writing to both publisher and subscriber for the same tables at the same time, you're good. You have a multi-master, but you're not writing to the second master unless the first master is down. You could also think about it that way. But when you compare the speed and the performance of the speed at which the replication gets in sync between the comparison between streaming replication and logical replication, I would say streaming replication is always the fastest when compared with logical replication. And of course, Patroni solved one of the problems, but one of the problems that does exist today with logical replication is, let's say you have primary 1, and that's a publisher, and you're replicating through logical replication to the subscriber 1. And it's the same data. You did not make any modifications on the subscriber 1. Let's say the primary 1 is down, and the failover happened to primary 2, but not the subscriber 1. In this case, the subscriber will not be able to catch up from where it stopped on primary 1, right? From the new primary. So you don't have failover slots with Postgres. Of course, there is some development that has happened recently for the newer versions, and also Patroni solves that by continuously storing the LSN and it's synchronizing that. So Patroni is one of the high availability tools for Postgres, which is open source, very heavily used, right? You don't have to really go for a proprietary solution for high availability in Postgres, right? So what I would say is you could use Patroni as a high availability tool, which could do automatic failover as well as not only automatic failover, even also if in case there is a primary that got demoted, it automatically resynchronizes that demoted primary with the new primary and adds it back to replication. You could also time your switchover or failover. You can say do a switchover at a certain time in the future, right? So it's pretty easy to work with Patroni, and Patroni will do a seamless seamless database failover, and it enables seamless application failover because in the application you could use a load balancer like HA proxy maybe, and that HA proxy is using the Patroni endpoints to detect what is a primary or a replica. So once that is done, it would be able to automatically redirect your writes to a primary all the time because HA proxy will be depending on your the Patroni endpoints to detect what's a primary. I could definitely talk more about that if anybody asks. I can point to some of my articles that I've written in the past. So talking about Postgres now, right? You have the advantage of writing procedural languages in whichever language you prefer. So you could use PL, PGSQL, or PL Java, PL Tickle, Perl, Python. There are several other procedural languages. So if you are familiar with Java and you want to write some procedures using Java, you could do that, or Python. So I remember one of the good use cases where we had a customer who wants to use global variables and who has this unique, I wouldn't say unique requirement, but a requirement of having the global variables, declared even in the exception handling, right? And in Oracle, it works well, but in Postgres, it doesn't. The session variables will not be applicable. Now, we rather had a wrapper created using PL Tickle, right? And we leveraged that in the Postgres PL PGSQL. So, you could maybe search for one of our articles around associative arrays for Postgres by MegaOps, and you would see more context around it. But anyways, the topic of discussion is not just that, but what I wanted to say is you could write procedural languages using anything that you prefer, any language you prefer. Talking about extensions for visibility, in Oracle you have lots of historic data capture happening as well if you enable, and that gets captured to some of the historic views. I remember DBA active session history or SS history, DBA underscore SQL text, DBA hist SQL text. There are several such historic views that capture and store history of statement executions to tell you how the statement or a SQL statement has performed in the past and what was the execution plan in the past. A similar such extension is available with Postgres as well, with pgstat statements. Though it doesn't record the execution plans and store them, right? I think it's still in a to-do list. I was talking to the author of PL/PGSQL, Janvik, and he said he would hopefully add that feature to pgstat statements. I will remind him. But pgstat statements gives you an opportunity to look at the history of SQL. How many times the SQL has been called, what's the total execution time, what's the average execution time, and is it hitting the blocks in memory or disk, or all of that information is possible with pgstat statements. By the way, I wanted to quickly also ask, how many of you are looking to migrate from Oracle to Postgres today, or in the process of migrating from Oracle to Postgres? Okay, and at the same time, I think, yeah, I see that you have pretty familiar experience now with Postgres. Okay, good. Okay, so other than that, even in when you talk about some extensions for maintenance, right? In Oracle, you have DBMS redefinition as an example, which could do or take care of the table reorg, like online table reorg. So if your table is fragmented, it could help you defragment that online without impacting the application completely. Similarly, you have extension called PG-Repack available with Postgres that could help you with online table reorg. And at the same time, for scalability, you have table spaces in Oracle with which you could distribute your I/O between different storages or file system, and you could also have faster storage for read logs. Similarly, with Postgres, you can also have table spaces to distribute your tables and indexes between different file systems to distribute the IOPS. And not only that, you could also have your PG vault, which is a write-ahead log segment directory, sim-linked to a faster storage. So it's always, you need to make sure that your transaction logs are written faster so that your transactions successfully happen faster. Now talking about some of the important differences around standard packages and the procedures you follow while migrating from Oracle to Postgres. In Oracle, you have sysdate, right? And so while converting the sysdate in Oracle, you might want to prefer using now all the time. This is one of the mistakes that I generally see when people are migrating from Oracle to Postgres. They think that now would be the right solution for sysdate in Postgres. Let's take an example here, right? Let's consider this example of we creating a table called test on Oracle and even on Postgres, and we inserting a couple of records. Just for simplicity, I've also created a sleep function here in Oracle, which is actually calling dbms lock.sleep. And now, if you would go ahead and look at this slide, right, where we are trying to compare sysdate in Oracle with now in Postgres. So I'm just running this select toChar. So when we execute this simple query on the test table, right, we see two timestamp values, right? And the toChar sleep function will run for every record in the test table here. In the first query output, we got a timestamp value 2 times, right? When we execute the same query, we got a different timestamp value 2 times in Oracle, right? Same timestamp value twice, and a different timestamp value other than the top one, again twice. Okay, so now let's see Postgres. When we execute this simple query on this test table, now we again got 2 timestamp values, And we are using now, the function now here, right? And pgsleep function will run, upon sleeping for 1 second, it will run the same again. So now you see the same timestamp as expected, right? However, when we execute the same query, right, we see the same timestamp but not a different timestamp like what we saw before here in the Oracle. So it's not the same behavior that you would generally see, right? Because in Oracle, when we executed the sysdate the second time, we got a different value, right? So now is always not the right alternative to sysdate, because it always returns the transaction timestamp, and it's unique for the whole transaction, right? So it's part of a single transaction, it stays the same. Now let us look at sysdate versus transaction timestamp. Okay, and it's the same example on the Oracle side using sysdate, but let's see what transaction timestamp did. So with the transaction timestamp, right, it's just the same behavior as we saw with now, because now is internally calling the same transaction timestamp, right? So you don't really see different timestamp as you have seen in Oracle here, right? So transaction timestamp is also the not the right solution here. Okay. Okay. Let's look at clock timestamp, because I also saw clock's timestamp being used a lot of times. Talking about clock timestamp, right? Again, Oracle behavior, we didn't change anything. It's just a sysdate. Here we see interesting behavior now, right? So in the query result, we got 2 different timestamp values, right? So we got 2 different timestamp values, but not the same timestamp value for the single statement here, right? When you executed the select command to return 2 timestamps upon sleeping for a second, you see the same, but you don't see the same anymore, because the clock timestamp function gives a different timestamp value for each record, right? So as this is again not this behavior that we want from Oracle, right? While migrating to Postgres, I would say, no, this is not a solution for us. So now let's go ahead and look at the statement timestamp. Now, as we see here, right, with the statement timestamp, right, we are able to get a similar results as Oracle. So the 2 records have the same timestamp. Here also the 2 records have the same timestamp, and these 2 have different timestamps, right? The 2 statements output. So what we do is, how many of you are aware of Oraface as an extension in Oracle? ORAFCE. Okay. I'll talk about that shortly, but we are comparing that with Oraface. Maybe I'll quickly talk about Oraface because that's pretty important. So if somebody lies to you that Oracle compatibility can only be achieved with a licensed Postgres and called some advanced Postgres or whatever, right? Then please do look at Oraface, because Oraface is an open source extension which is heavily contributed by a lot of Postgres contributors. Also, I mean, we also do some contributions there, right, to Oraface, and we heavily do contributions to Oraface. It gives the compatibility to a lot of Oracle's standard packages, right? So you talk about date functions, you talk about some regular expressions, right? And at the same time, you talk about sysdate, you talk about dual table, right? DBMS output, UTL file. Even Oraface mail is another extension that you'll also have to look into, DBMS pipe. All these Oracle standard packages, compatibility is added to Oraface extension. So what I was trying to do here is trying to compare the statement timestamp with Oraface extension to see if Oraface does the same or not. And it's not a surprise because Oraface, of course, is a very robust extension that is heavily used by people migrating to Postgres. Oraface internally, if you go and look into the code of Oraface, it uses statement timestamp as what we have seen in the previous slide. So this means that Oraface ends statement timestamp both, like Oraface's sysdate and the statement timestamp function are giving the same results. So you see the same timestamp being retrieved by for the two records, and a different timestamp but same for two records retrieved here as well, or so it's an expected output because it's in line with statement timestamp. Quickly, we'll look at some of the mistakes that are being done while writing hierarchical queries for Postgres. Right? Again, you can still use with recursive. It's not at all a problem, but you need to write it the same way, right? Because Oracle supports even the common table expressions using with, right? And it also supports a with recursive as well, right? And internally, you could also use connect by prior, right? That's Oracle only, and it's not non-ANSI standard, non-ANSI SQL standard. And at the same time, in Postgres, we have with recursive. So here, people make mistakes while converting Oracle code by assuming that the with recursive, without a proper rewrite, will just do the same. Will just print the same behavior, because with recursive or the connect by prior in Oracle does a depth or a breadth first, but by default the connect by prior does a depth first search, and Postgres does a breadth first search. So we could go ahead and look at that, right, as an example, and maybe consider this example, right? So if you consider this example where we created a table called HR and we inserted a hierarchy like employee ID 1, no manager, but employee ID 2 has manager as 1, 3 has manager as 1, 4 has manager as 1, and 10 as manager as 2. So we have such hierarchy built. So the same is also inserted to Postgres, right? Now, let's use connect by in Oracle. So if you use connect by in Oracle, the simple query, go ahead and return the managers with their employees, right? We see clearly the behavior of connect by as a depth first search here, right? So you see, oh, this one, yeah, I should have had a black background over here or an ash background. Maybe I took that off. But what I would say here is it's doing a depth first, right? Whereas you will not see, the same output format if you just used a plain with recursive this way without properly rewriting it to make sure that it just prints the way it should when compared with Oracle, right? So the top, like I would see here that while the Oracle is doing a depth first search, right, the entire top bottom hierarchy is being calculated for every record one after the other, right? Employee ID 1, employee ID 2, there is a hierarchy that's being printed based on a top bottom hierarchy. And let's see what we could do with Postgres here, right? We could also use table func as an extension simply, and it's available with Postgres contrib. So with this table func, you can just go ahead and use the same connect by function to go ahead and print a depth first, like how it is with Oracle. Or you rather need to add an incremental level to with recursive to also go ahead and print same as what Oracle does. So I would say some of such challenges do exist when you're migrating, right? Of course, there could be a lot more. If it would have been a 4-hour tutorial, definitely there would have been a lot of things that I would have tried to cover, but I would say migrating from Oracle to Postgres is definitely not a tricky thing. It's just that you need to use the right approaches, as like you need to explore through, maybe some experts if required. But I would say almost everything that you want while migrating from Oracle to Postgres is achievable, and it's always not a good practice to try proceeding with a proprietary model unless you figured out that it is truly not possible with open source and Postgres. So with this, in case you have any questions, I would let you ask. If not, we should be good, right on time.